Hello, everyone. So, we have a guest here that flew all the way from Switzerland. Welcome. So, thank you, everyone. Today is our last topic, and we're going to have a Max Gfeller.
Gfeller,
Gfeller,
yes.
okay. You will introduce yourself a little bit, right?
Yes.
But before that, I would like to ask you one question. We have a quite huge audience here, knowing that this is not the main stage. What are we going to learn? The three things that we are going to learn after your session.
Well, this talk is going to be about offline first web applications. So we're going to learn first what are offline first web applications, then why we should make our applications offline first, and then how to do this, I guess.
Right. Okay, so are we ready? Yay! Okay,
Thank
stage
you.
is yours.
Thank you. All right. Welcome to this presentation about offline first web applications. My name is Max. I'm from Switzerland. I'm a front-end engineer at Waytech. And I'm also the co-founder of a startup called Living Room Events, where we do digital and hybrid events. You can find me on Twitter at mgfeller. All right, I'm going to be talking about offline first web applications today. I will start with a little introduction. Can you see this, by the way? Okay. I will start with a little introduction. I will show you the web technologies that make this possible. I will show you some of the tooling that already is around. And in the end, I'm going to be talking about our approach that we went with. Now, when I say our approach, it's actually the company I previously worked for. It's a Swiss web hosting company. And we did like very classical shared web hosting, and I guess one of our biggest products was email, because like everyone used email. It's just when people signed up to use our webmail application, this is what they were greeted with. This is Roundcube, and Roundcube is amazing. It has been around since forever. It works really well. It's just it's a bit old now. It's not that fresh anymore, right? And yeah, we wanted to replace this with a more modern version, and I was tasked with building this webmail application. And well, for us, it was clear it should be a progressive web application, right? Everyone is doing PWAs these days. But how do we define progressive web applications? So the term progressive web application, or PWA in short, has been first coined in 2015 by the Google Chrome team. And they defined it as like this next generation of web applications that should resolve the following criteria. So first of all, it should be really fast. It should load instantly. Then it should be integrated, meaning that it should feel like it's part of the device. It should feel like it's a native application. It should be reliable. This is a very important one, I would say. So it should work with bad or no internet connection as well. And it should be engaging. So users should be able to engage with the application even if it's not open, right? As you do with mobile apps as well. Now, when we look at the progressive web applications that are already out there, I would say, and this is just my own personal opinion, but I would say most of these are not really progressive. And I will show you what I mean by that. So this is Twitter. You've all seen Twitter. And Twitter is always like hailed for its very good PWA. And yeah, it loads instantly, and it feels like a good application, right? It's just that if you open Twitter without having an active internet connection, this is what you see. So the application is still here. It loads instantly, But what good is it if you cannot do anything, right? You cannot look at old tweets, you cannot write new tweets, and you cannot send direct messages, right? There's not that much you can do. You can just take a look at the empty application shell. But it's still much better than the next example. Next example is Gmail. I opened this in Chrome, Google Chrome, opened Gmail, had it open before, and I don't see anything, right? Now, when we are talking about offline first web applications, we are always thinking of maybe someone who lives very far from society, maybe in a rural area, whatever, right? But we don't have to look that far. I am one of so many people that commute to work every day by train. And in a train, I do have internet connection. It's flaky at best. And yeah, using the web on a train is a pain. And like the time I am in the train, I would love to be able to use, like, already look at emails, maybe respond to emails, right? And yeah, with the Gmail not even loading, that's gonna be a problem, right? But like with native email applications, like Apple Mail that I'm using, it works like a charm. Even without internet, I can just look at all the emails I already downloaded. I can reply to them. I can send new emails, right? And it just gets synchronized whenever there's an active connection again. So I thought to myself, why is that? Why can web applications not do that? And to find out a bit more about that, let's look at the technologies that I think should make this possible. First of all, service workers. That's the most crucial piece because they make our web application work offline. They can be installed from a web application. They run in the background. They can intercept requests. And they can communicate with our web application. So this is how we would use a service worker, or how we would register a service worker. We just do a navigator.serviceworker.register, and we pass it the path to our service worker JavaScript file. What we get back is a registration which can have multiple, like one of multiple states. First one being installing, then waiting after it has been installed. And if it has like replaced the active service worker, then it is active. We can use our service worker. And the service worker kind of sits in between our web application and our backend. All of the requests from our web application go through the service worker. And in case that there is no connection between, like no connection to the server, be it because we don't have internet connection, or maybe because the server is not available, then the service worker itself can respond to requests as well. This is what makes our app work offline. And we can respond to requests by using the cache API. But the cache API allows us to interact with the browser's built-in cache. So you can only cache like request and response pairs. And yeah, it can be used inside a service worker. This is how we would use this. So this is in our service worker. So first we create like this new cache, static. We can give it any name basically, and then we add to the cache the /cat.jpg. So what it does is it makes this request, and it caches the request and the response, which is just an image of a cat, and we have that in our cache now. Now what we can do now is in our service worker, we can listen to those new fetch requests from our web application. And in here we can do a little check. We check if the path name is /doc.jpg, so we want to render an image of a dog in our web application. And what we instead can do is we respond with the cat image instead from our cache. So as you can see, this allows for some bamboozlement. Another very cool API is the background sync API. The background sync API is allowing us to do requests even after our web application has been closed. It is not a standard, unfortunately, and you can only use it in Google Chrome and Edge. But it does not require permission. So if your user uses Chrome or Edge, you can make use of this API. This is how it would work. Inside your application, you wait for the service worker to be ready, and you do a sync.register. So you register for a new sync request. You give it a tag, could be create user. We would probably pass some details there as well. And inside the service worker, we can listen to those sync events, check the tag, and then execute our action, do the request. And as I said before, we would probably pass some details in there as well. So if the user is connected to the internet, then this gets executed immediately. But if the user is like offline, then it only gets executed as soon as they get an active internet connection again, and it gets executed even when the website has been closed, which is very cool, I think. So the pros of this obviously are, well, we can do requests even after the page was closed. It's very cool. There's a few cons as well. I would say it's I feel like it's a bit awkward syntax. It feels a bit weird to use, right? You need to have some application logic in your service worker, what maybe is not that cool for like separation of concerns. And yeah, as I said before, unfortunately not a standard, but nonetheless, very cool API, and I hope it will one day be supported in all the browsers. Okay, now when we want to save data, right, in an offline application, we probably want to save a lot of data locally so we can still show something. There's a few options that we can use. So first of all, cookies. Cookies have been around like forever, right? Then there's web storage, which includes local storage and session storage. And then there's IndexedDB. Storage-wise, a cookie allows us to save 4,096 bytes of data. It's not that much, but I mean it's enough, I guess, for like some authentication tokens, maybe some settings, right? But then already for web storage, the limit is 10 megabyte. And 10 megabyte, that's already a lot of text, right? But IndexedDB, like in theory, is unlimited. We can save lots and lots and lots of data in IndexedDB. And it's only limited by the user's disk quota, basically. So here's a screenshot from the web application we've been working on. This in my Chrome. As you can see, it used 115 megabytes, which is a lot, most of it from IndexedDB. And it also shows me that the available storage quota is like 596 gigabytes, which is like so much. Although that being said, at the time when I took the screenshot, I only had like 200 gigabyte free on my hard disk, so it's not always that reliable what you see here. So that's cool, right? We can save a lot of data. Well, there's a problem, and the problem is the LRU policy. Now the LRU policy is triggered as soon as all the available disk space on our user's hard disk is used up. And the browser's quota manager starts to clear out data based on the least recently used policy. And it will delete as much data until there is enough space to fulfill the request that originally triggered the policy. That is kind of bad news for us, right? Because we want to make use of like IndexedDB to save save the user's actions that maybe have not been synced with the backend yet, right? So, and if it can just get deleted, that's we could lose this work, right? So there's an API for that. It's called the persistent storage API, and it allows us to make our data persistent. Now, it is unfortunately not yet supported on Safari. Can be requested by a web app, and yeah, it makes your data persistent instead of just temporary. Even if the LRU policy gets invoked, it will not delete your data. So this is how you would make use of that, or how you would ask to use it. First of all, you would probably want to check if your browser supports it, right? And then you just do navigator.storage.persist, and what you get back is a Boolean value if the request has been granted or not. Now, how is the permission granted? Well, in Firefox, it's quite easy. It just asks the user, and the user has to say allow or don't allow. But for Chromium, it gets a little bit complicated because it will not ask the user. Instead, it will take a look at like how high is the level of site engagement, how much has the user interacted with your site, right? It also checks if the site has been installed or bookmarked, and it also checks out if the user has like granted other permissions, like to show notifications. Now it takes all of that into consideration, and it says yes, granted or not granted. So that's very important to know, because if you want to make use of this persistent storage API, you should not ask the user like very first thing when they visit your site, but instead just wait a little bit until they interacted more with your site. And chance is higher that this request is being granted. Okay, and yeah, there's some more additional APIs that browsers support nowadays, like the file system API, file API, notifications API, push API, message and broadcast channels, and many, many more, like web Bluetooth. And those are all APIs that are not needed to build offline first web applications, but they kind of close the gap between web applications and native applications. So all of those APIs that I've shown now are, I mean, except for the background sync and the persistent storage API, they are supported in like all the major browsers today, and yeah, they can be used today. So with that being said, let's maybe look at the tooling that already is around for creating offline first applications. So first of all, there's Workbox. Workbox is like a toolbox for service workers. It was built by Google, and it consists of different modules and libraries. And yeah, if you have to, or if you want to implement service workers, then I would recommend that you just use Workbox, because it can be kind of difficult doing that on your own. And Workbox just like has so much different caching strategies, all of that already implemented. It's much easier. Then another very interesting tech that's already out there are like replicating databases. First one I think was PouchDB. PouchDB is like the JavaScript implementation of CouchDB that runs in your browser and can just replicate CouchDB, which would allow to like create data-heavy applications, for example. And then there's RxDB, which is like a real-time database, but it's just replication basically inside your browser. Another very cool project I think is Replicache. I have only learned of this project like half a year ago. I'm not sure how long it has been around, but I think it's quite new still. And Replicache is cool because it allows you to build offline first web applications, can theoretically work with any backend. It also does like some replication, but you need to like install some kind of server part or need to implement some kind of server part to make it work with your own backend, right? And yeah, besides that, there's a lot of those serverless applications or frameworks out there, like Firebase with Firestar. There's MongoDB Realm. There's AWS Amplify. And all of those also kind of make it easy to create offline capable applications. Now, the approach that we went with is kind of different. So this is a kind of a simplified architecture that we are using. Oh, okay. So we have our front end, like our web application that just communicates with the REST API. And the REST API more or less just a proxy for like email servers, stuff servers behind it, right? So it's not really a conventional backend in any sense. Yeah, we also cannot really choose database, so we cannot really make we cannot just say, okay, we are doing this in CouchDB. It doesn't work. Our backend is just email, right? And yeah, it's also dependent on those third-party systems, Steph and email. Okay. Also, we had like a very specific idea of how in the front end it should work. So let's take this little use case of sending an email. So if a user sends an email, then it should do those things regardless if there is a internet connection or not, right? So it should remove the email from the drafts folder. It should decrease the number of active drafts. It should add the email to the sent folder and increase the number of emails in that folder. And that then as soon as we have internet connection, it should try to send the email. If it was successful, then maybe we show a notification, maybe we don't show anything. If it was not successful, we kind of reverse those local changes and put the email back in the drafts folder and show some kind of notification that it has failed, right? And those kind of actions are not really possible with Replicache, at least as far as I can tell right now. So we came up with yet another framework. We called it RMIJS. We called it RMIJS because it was inspired by this guy. That's a hermit or eremite, and it's like a person that lives secluded from society, usually for religious reasons, and only sometimes has contact to other people, and that like bring him something to read or bring him food and stuff. So RMIJS is backend agnostic. It can work with any backend basically, be it a REST API, GraphQL API. It does not require you to implement something specific, right? It's just you can use everything. It is built on top of U3's reactivity API, but it can be used with every other front-end framework. It is not built upon a service worker. It just needs service workers to make the web application work offline. So the advantage of that is, I guess, that it could be used in native applications as well. Like think Electron, think React Native. And as of right now, it is kind of meant to be your application's logic layer. Um, this is our web application. This is our JavaScript code. The RMIJS store would kind of be between the web application and the service worker, respectively the backend. And inside the RMIJS store, we have resources that are meant to replicate resources that you have on your backend anyway, but you can structure it any way you want, of course. All of those resources have their own state that gets persisted to IndexedDB. And yeah, let's take a look how we would implement such a resource. Let's start with the settings resource. First thing we have to do is we need to define some state that this resource has, right? So we have like those two settings, the language, default is English, and notifications enabled, which is false, the default. Now we would probably implement some kind of fetch method, which fetches the data from our backend and saves it to our state. And we could also implement an update settings method where the user does some changes in their settings, maybe changes language whatsoever. What it will do, it will just do a patch request on the server. Now, the problem of that is, right, it doesn't work if there is no internet connection. So there's a bit more, like RMIJS makes use of this decorator API. We are using two different decorators here. First of all, one being a queuable means that this method is not being executed immediately, but instead goes through the RMIJS store's action queue, which only is being processed when there is an active connection. And the second one is a mutation, and the mutation is very cool. I think this is very unique to RMIJS, I guess, because it allows us to modify our local state in the way that we expect our backend to modify our data, right? So what we're doing here is we are saying the state is just that we're just updating the state with the new settings. What would happen now is that our user switches languages. It will maybe, let's just assume he doesn't have an active internet connection, and yeah, we can still immediately show the new information already. Change the language and everything. So this is our settings resource. This is how we would use it. We define like our RMIJS star. We give it a name. We give it the resource. Can have multiple resources as well, of course. And we do have like this connection indicator, which indicates if there is a connection to our backend or not. And the default is like just it checks if the browser is connected to the internet or not. But it could be a bit more sophisticated as well, right? So we could implement our own connection indicator that checks if the backend is available and healthy and everything, right? Okay. Let's look at the practical example. This is a screenshot from the application I've been working on. And yeah, it's a email client, right? So we have our list of mailboxes, and after every mailbox, we have this little batch showing the number of unread messages inside of that mailbox. So let's implement a method called toggle read, where we can update this read status. So this is in a different resource, by the way. It's probably in a mails resource, and it doesn't do that much, right? It takes the folder, mail ID, and read, which is true or false, and it just does the patch request. Now, we can once again use the queuable decorator and the mutate decorator, and we just update our state. We say state.items, we find the specific item, and we set red to like red, which is either true or false. Now, in this example, the list of folders that we saw on the sidebar, that's in a different resource. And for that, we have like a special helper function called mutate resource state, where you can mutate the state of another resource. And this is now the folders resource. We find the specific folder and we set unread either plus or minus 1. Okay. Also, those mutations, they are not like committed to the local state per se, but they are tied to the action, and if the action fails, if it's not successful, then we can just revert those mutations. But let's quickly take a look at how this looks like in our application. So this is our whole email application. As you can see, I have the inbox folder open. There's 2 messages in there. One is unread, the other is read, and the batch shows 1 unread message. So what I'm doing now is I go to Chrome's network tab and I say we are now offline. And I toggle read. As you can see, it is now unread. It shows now 2 unread emails in this box. And if I go to application, IndexedDB, there's like an action queue, and in there we have like 1 item, this update mail, with those parameters. That's the mail ID, that's the red, which is false. Now, it didn't make any request yet for that, right? Now I enable it again, and as you can see, it immediately executes the request, and this is now committed to our state. The request was successful. Status code 200. We still see the changes, right? And when I refresh it, the action queue is now null. It's now empty. And yeah, what happened in the background is it executed this action. It was successful, so it took this mutation and it committed it to our local state. And yeah, that's it. As you could see, this works even if there's no internet connection. Now, RMIJS is unfortunately not yet open source, and as I've said before, I'm not working at this company anymore, but we are very committed to release this as an open source project. If anyone is interested, I prepared like a little form. So if this is something that you think you could use, just please fill out this form, and I will get back to you as like before we release it, like add you as an early test person. Did y'all have a chance to scan it? Perfect. All right. With that being said, thank you very much, and you can find me on Twitter at Gfeller. Thank you.
Do we have any questions? Yay.
Hello. Thanks for your talk. It was a very interesting topic. And I have a question. Do you create this app for like email app as a client, or do clients have to download this this app? Because like if you're creating a new client, then it's what is the difference with other clients? Like,
Okay, so the question was what's like the difference with other email clients. So the main goal was just having a replacement for this Roundcube webmail client that we are using now, and that our customers, which have like web hosting accounts with us, where they can set up email accounts, right? That they can just use this webmail. But I guess maybe there's plans to, I don't know, do more with it in the future. But as I said before, I'm not there anymore, so I wouldn't know. So the question was if it's difficult to make an existing web application offline capable, right? That's a very good question, and it's something that we are working on right now, because it's if you start a new RMIJS project, and you would kind of have to use like this own store and everything. But we are working on a way to make this more like easier to integrate into existing applications. And yeah, so our vision is kind of like it should be like the progressive offline first framework, I guess. So where you could start that you just add it like as a plugin for your state management tool, which could be like Redux or Vuex or Pinia whatsoever. And yeah, then add more and more functionality to it as you need it. That's the idea. Yes, yes, exactly. And yeah, that's actually what we are working on right now to like integrate it into existing state management tools. So we could just, well, start using it with one line of code, basically. Are you talking about the LRU policy? Or okay, so the question is, what's the like what's going to happen with the LRU policy, I guess. Um, yeah. So the question is like, how strict is it, and if that changed over time? I don't think it has changed. Maybe I don't. No, I don't. I don't think it has changed much. But I think like the Google Chrome team, they did like studies on how this actually affects web applications, and it showed that. So first of all, it is not that often that this policy is being triggered. And if it is being triggered, it is usually for applications that haven't been opened in like very long time. So maybe in practice it's not that much of a problem. Thank you. Thank you very much.